Hello. So what I'm going to look at today is loudspeaker peak power and loudspeaker RMS power. RMS stands for root mean square. What I'm going to do is I'm going to sample some music with a sampler, and then I'm going to play it through this simulator, and it will show me the peak power and the RMS power. Okay, so what I've got here is the LTSPICE simulator, and I've got a voltage source here where I've got wave file equals, and then I'll type in what the sample's called after I've sampled something, and that's going into a 1 ohm resistor. Now the wave file will be normalized to 0 dB, which means it's got a maximum amplitude of 1 volt. I'm then using these behavioural voltage sources to simulate a bridged amplifier with a 100 volt peak voltage output. So V equals V in times 100 means that this amplifier is 100 volts positive, and then this one here, V equals V brackets P, which is that net there, times -1, which makes this amplifier in 180 degrees antiphase to this amplifier. So the resistor is connected in a bridge configuration. Okay, so now first of all I need to get some music. So I'm going to go to, just bear with me a second, more programs. Right, I've got this here. Right. Okay, so this is my sampler, and now if I go to YouTube, YouTube, take some of the born slippy underworld, and where we've got those throbbing bass bins here. So I'll record a bit. Stop. Right, don't need YouTube anymore. Right, so I've got my throbbing bass bins. Now I don't need all of that. I just need a bit of it. Oh, I didn't want to do that. Delete. Right, so what I want to do now is copy a section of it. So I'll copy from the start of a beat, copy 4 beats, copy, file, new file, don't save, paste. Right, so we've got a few beats there. Let's just play that. Right, now what I'm going to do is I'm going to normalize this. Edit, somewhere's effects, normalize. So normalize it to 0 dB, apply. Right, now save file as WAV, I'll call it born1.wav. save that. Okay. Now go to LTSPICE. Oh, where did it put it? File. Save file as. It put it in new class GH amplifier, right? Okay, so now go to in here. There should be something called born one.wav. There it is. Let's play it. Right, so okay, I don't need to use a sampler anymore. Turn that off. Go to here. Put in wave file equals born one.wav. Okay, now I'll set my transient to play 5 seconds. Right, now if I run a transient analysis for 5 seconds, I should see that sample. There's a sample there, and it's 1.385 seconds long. Right, so I set the transient to 1.385. Okay, now I'll do it again. Right, there you go, there's the sample, and you can see it's normalized to 1 volt. Now if I look at the output from these models of amplifiers, I should see 100 volt. Yeah, I do see 100 volt. And then the other one is in antiphase, so if I cross probe it, across there, I should see a peak of 200 volts, which I do. Right, now if I go and do the power, so the power into, I just put power on there, so the power into a 4 ohm impedance loudspeaker with a bridged amplifier running at plus and minus 100 volts is 10 kilowatts, which makes sense. But if I look at the average power that's calculated from the root mean square of the voltage, I get why is that not working? I have to halt the simulator. Hold on, it's not working for some reason. Halt. I might have to restart this because it's somehow not stopped. Right, okay, it's stopped now. Right, so I've got, go back to this again. So I had 10,000 watts of peak power, and my I'm going to have to restart this power. Right, let's do it again. Power. Okay, so there's my peak power, which is at the 10,000 watts. And now I should be able to get my RMS power. There we go. So my average power is 196 watts. So you can see that there's a huge difference between the peak power and the RMS power. So with a 10,000 watt amplifier and this particular sample, there's only 196 watts average. But this is as it come off YouTube without any equalization, because in a nightclub you would quite often put equalizers on the bass to increase the sound pressure level of the bass up by as much as 20 decibels. Okay, so there you go, so it's 196 watts. The next thing to look at is an FFT of the sample, which I did earlier because it takes a while to do that, and see where all the energy is. Okay, so this is an FFT, fast Fourier transform, of the sample, which was very similar to what the sample I just took. And you can see that most of the energy is at 200 hertz. You've got some energy here at 1, 2, 3, 4 hertz. This is your beats per minute, your 270 beats per minute. Beats to the music, and then these are the harmonics of that. Okay, so there we go. Alright, thank you, goodbye.